Hey, welcome back. Chemistry's fun when we understand it. In this next video of my series on titrations, we're going to be dealing with the calculating the pH before the addition of any titrant. Remember, this is our setup. I have a couple of other videos where I go over the different points that we can find in our titration curve. The idea is that we're calculating the pH as we are adding more titrant. This particular video is that point at the very beginning of my titration, 0 milliliters of your titrant added. Remember that in every single case we have to look at the composition and the volume, adjusting accordingly. So the final volume on your flask is always going to be titrant plus sample. Since we haven't added any titrant, the final volume really is just the volume of my sample. The same thing with the composition. I haven't added any titrant, so the composition is only going to be given by what I had at the very beginning. So the main premise is always identify the composition of your mixture in the flask, recalculate concentrations as appropriate. Before adding any titrant, you only have the analyte present. You don't have to do any corrections. For this, we can use a regular rice table. Now remember that this table is all in molar concentration. The initial is given in the problem, 0 and 0 for the products, changes minus X for the reactant, plus X for each of the products. At equilibrium, initial concentration minus X for my reactant, and X for each one of those products. Since this is a weak acid and we are given already Ka, we can write down the equilibrium expression for Ka. That is, remember, products over reactants. In this case, the numerical value is given in the problem. We look at the equilibrium row in my rice table. Both of these products are equal in concentration at equilibrium, each of them X, so we end up with X squared, and initial concentration minus X goes in the denominator. This one is going to give me a quadratic equation. Remember, you can solve this any way you want. Now, what you always have to pay attention for your specific problem is this value of X that you're solving for in this quadratic equation, it's always associated with the species that changes the pH. In this case, the association is X equals the concentration of the hydronium ion. So the roots that we get from that quadratic equation, we only take the one that makes physical sense. In this case, we're going to take the positive root. That's going to be equal to the concentration of the hydronium ion. Minus log of that concentration gives me directly the pH. 2.88, and that's actually what we were expecting, because even though this is a weak acid, at the end of the day it's an acid. Since we only have that weak acid present, we're expecting the pH should be lower than 7. Okay, at the beginning of any titration, before any titrant is being added, the problem really is just the composition of your flask. In this particular example, that was a weak acid. I'll see you in the next video for a calculation of the pH once we have passed the equivalence point. Talk to you soon.